A previous video focused on functions and plugging values in and inputs and outputs, but this particular video is going to focus more specifically on what happens when we plug an expression in for x. So that'd be like 5t. So instead of just a 7 or a 5 or an x, you're plugging 5t in, or a plus 4. And so that requires just a little bit more order of operations, but essentially it requires the same thought process where if you're given an f of something other than what you originally have here, like an x, so here 5t, that means I just want you to plug 5t in for x and then simplify. So let's look at that first example, f of 5t, and that means I want 5t to go in place of x right here, and so that's 10 times 5t, then plus 7. So now you just simplify. 10 times 5t is 50t plus 7. And these are not like terms because this is a t term, so that's it. That's your final answer for f of 5t. It's 50t plus 7. So what you notice is that if you have in your input, because that's the location of the input, of an expression or a variable or a constant like t or something, you're going to have that in your answer, and that's okay. You're not going to end up with an answer like 50, 57, 10, or something like that. You're not solving for t, you're evaluating your expression at 5t, and so you're going to have a t in the answer. So let's take a look at g here. We have g of a plus 4. So that means we're plugging a plus 4 wherever we see x. So negative 2 times a plus 4 goes in for x. That is going to be squared plus 7. Now you have to do your order of operations. Squaring comes first of your binomial, so that negative 2 is going to sit out front for a second, and you're going to have a squared plus 8a plus 16, because that's what a plus 4 squared is, then plus 7. Now at this point, we can distribute our negative 2, so you have negative 2a squared minus 16a minus 32 from the distributive property, and still plus 7. And now we can combine our like terms.